Testing 1 2 3. Testing 1 2 3. Ah, microphone seems to be a little bit softer than it should be. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. There we go. Levels appear to be good. Okay. Hello, hello. Welcome in, welcome in. So, today is the third stream for August 20th, 2026. The third practice stream or study stream for August 20th, 2026. It is currently 5 o'clock here on the West Coast, and I have 2 hours to study. And what is the study? It is the Elements of Arithmetic by Augustus De Morgan, and really studying, I'm more reviewing the arithmetic. I'm studying the actual Gregg Anniversary shorthand, the system of handwriting that allows you to write more brief notes. So with that, got everything pulled up here. Let's go ahead and get into it. So any links, if you're interested in any of the information that I'm using, it's available all down in the doobly-doo, as they say. So let's go ahead and get started. We're currently, see, I had just finished up, where's my glove? There. So I just finished up Article 118, and we're starting Article 119. So let's see how many articles we can get done. Now. Okay, so we're here, and I think we had read through that section. We had gotten to fractions, the end of 18. I don't think I had read through 118 yet. No, I had. Yeah, that's right, because it was an extremely long section. So we're ready to go. Let's just continue on with our work. Article 119. So everything's set up, and we drop a paragraph marker, and we start. So 119. If this product 21,000 if this product 21 over 32, and that was the reference to the previous article, okay, which you can see at the end of the previous stream. If this product (21 over 32) is to be multiplied by a third fraction, for example, by 5 over 9, the result is by the same rule, (105 over 288). And so on. The general rule for multiplying any number of fractions together is therefore And then here's our next paragraph. Multiply all the numerators together for the numerator. Of the product. And all the denominators together for its denominator. Next paragraph, I'm not going to read 119. 120. Suppose it required to multiply together to multiply 15 over 16 and 8 over 10. The product may be written thus. Fifteen times 8 over 16 times 10 and is 120 over 160, which reduced to its lowest terms lowest. I remember we just did the lowest. Here it is. Yes. ST. Yeah, according to Article 109. Is going to be 3 over 4. Let's go to add another page below. Is 3 over 4. This result might have been obtained directly. Might, that's right. Might have been obtained and then directly by observing that 15 and 10 are both measured by 5 and 8. And 16 are both measured by 5, comma. And 8 and 16 are both measured by 8. And that the fraction may be written thus. And essentially an expanded form. 3 times 5 times 8 all over 2 times 8 times 2 times 5. Divide both its numerator and denominator by 5 times 8. According to Article 108 and Article 87. And the result is at once 3 over 4. Therefore, before proceeding to multiply any number of fractions together, let's see what proceed is. Yep. Therefore, before if there be any numerator and any denominator, whether belonging to the same fraction or not, which have a common measure, divide them both by their common measure. Which have a common measure, divide them by that common measure, divide them both, by that common measure, and use the quotients instead of the dividends. Instead of the dividends. There we go. And that is the end of 120, correct? No, and then we have a little bit more. Next paragraph. A whole number may be considered as a fraction considered is cons, I believe. Just curves that way. Let's go ahead and check that out. Considered. Oh yeah, this is the one that flips backwards. Considered. And is it a disjointed? Yes, disjointed. A whole number may be considered as a fraction, as whose denominator is 1. Semicolon. Thus, 16 is 16 over 1. And that was according to Article 106. And the same rule will apply when one or more of the quantities are whole numbers. Same rule will apply when one or more of the quantities are whole numbers. All right, and then the rest are just exercises. So we skip that. Consult textbook for exercises. Consult textbook. There we go. All right, we skip here. That's all of 120. So let's go ahead and reread through that. Okay, so we go back through 120. Suppose we required to multiply. So we go back up, find our marker, or paragraph marker. There it is. And we read over it. Here we go. 120. Suppose it required to multiply together 15 over 16 and 8 over 10. The product may be written thus as 15 times 8 times 16 over 10, and is 120 over 160, which reduced to its quotient? No. Lowest. To its lowest terms, according to 109, is 3 over 4. This result might have been obtained directly by observing, add a dot for observing, okay, observing that 15 and 10 are both measured by 5, and 8 and 16 are both measured by 8, and that the fraction may be written thus as 3 times 5 times 8 over 2 times 8 times 2 times 5. Divide both its numerator and denominator by 5 over 8, according to Article 108 and also Article 87. And the result is at once 3 over 4. Therefore, before proceeding to multiply any number of fractions together, if there is any numerator and any denominator, whether belonging to the same fraction or not, which have a common measure, divide them both by that common measure, and with the quotient in instead of the and with the quotient, or and what is it, and add the quotient, and use the quotient. There we go. Yeah, use. Oh, there we go. And use the quotient. So let's go ahead and fix that. There we go. Use the quotient instead of the dividend. A whole number may be considered as a fraction, whose divisor is 1. Thus, 16 is 16 over 1, according to Article 109, and the same rule will apply when one or more of the quantities are whole numbers. And then here we have consult textbook for examples. All right, and now we jump down to Article 121. Article 121. So let's go ahead and drop a paragraph marker, give it a little highlight, and zoom down the page. 121. All right. In dividing one whole number by another, for example, 108 by 9, this question is asked. comma, and then hyphen. Can we, by the addition of any number of 9s, can we by the addition of any number of 9s produce 108? And if so, how many 9s will be sufficient for that purpose? Check purpose, PRPR. Nope, just PRP. Suppose we take two fractions, for example, 2/3 and 4/5. And ask, can we, by dividing 4/5, into some number of equal parts, and adding a number of these parts together, produce 2/3. If so, into how many parts must we divide 4/5? And how many of them must we add together? The solution of this question is still called the division, of 2/3 by 4/5 and the fraction whose denominator is the number of parts into which 4/5 is divided, or into which 4/5 is divided. And whose numerator is the number of them which is taken. Is called the quotient. The solution of this question is as follows. Let me go ahead and write another level down here, another page. Okay, so we need elements of arithmetic. Section 5, and this is page number 12. Hopefully we're near the end, because otherwise I'm going to have to split this up into another page. Yeah, we might go to page 12, and then we'll have to add another one. Okay. Dun, dun, dun. Okay. And whose numerator is the number of them which is taken is called the quotient. It's called the quotient. Period. The solution of this question is as follows. Check solution. Oh. Yep, that is solution. The solution of this question is as follows. Reduce both these fractions to a common denominator. According to Article 111, which does not alter their value, and that's according to Article 108. Which does not alter their value. Alter their value according to Article 108. They then become 10 over 15 and 12 over 15. They then become 10 over 15 and 12 over 15. The question now is, to divide 12 over 15 into a number of parts and to produce 10 over 15. Into a number of parts and produce 10 over 15 by taking a number of these parts. Since 12 over 15 is made by dividing 1 into 15 parts, and taking 12 of them, if we divide 12 over 15 into 12 equal parts, each of these parts is 1 over 15. If we take 10 of these parts, the result is 10 over 15. Therefore, in order to produce 10 over 15, or 2 over 3, according to Article 108, we must divide 12 over 15, or 4 over 5. Into 12 parts. And take 10 of them. That is, the quotient is 10 over 12. If we call 2 over 3 the dividend, and 4 over 5 the divisor, as before, the quotient in this case is derived. Derived, oh yes. Oh. From the following rule. Which is the same reasoning, or which the same reasoning will show to apply to other cases. The number of the quotient, keep on going, so I'll go to the end of Article 121, and then I will go back and read 120, all of 121. Here we go. The numerator of the quotient is the numerator of the dividend. Running out of room. Let's move down here. Multiplied by the denominator of the divisor. I'm blank. Oh yeah, denominator. Of the divisor. The denominator of the quotient is the denominator of the dividend. Denominator of the quotient is the denominator of the dividend multiplied by the numerator of the divisor. The rule is the reverse of multiplication, or this rule is the reverse. And reverse, I believe, it's just REV. RVES. This rule is the reverse of multiplication. As will be seen by comparing what is required in both cases. In multiplying 4 over 5 by 10 over 12, I ask, if out of 4 over 5 be taken, ten parts out of 12, how much of a unit is taken? And the answer is 40 over 60, or 2 over 3. Again, in dividing 2 over 3 by 4 over 5, I ask, what part of 4 over 5 is 2 over 3? The answer to which is 10 over 12. And thus concludes Article 121, which means I now need to go back and reread the article before proceeding with 122. And looking through, addition, this was a fairly long article. There we go. It is here. Let's proceed. In dividing one whole number by another, for example, 108 by 9, this question is asked, can we, by the addition of any number of 9s, produce 108? And if so, how many? I believe it's how many 9s, right? And if so, how many 9s will be? So we need how many. Let's add that here. How many 9s will be sufficient for that purpose? Suppose we take two fractions, for example, 2/3 and 4/5, and ask, can we, by dividing 4/5 into some number of equal parts and adding a number of these parts together, produce 2/3? If so, into how many parts must we divide 4/5? And how many of them must we add together? The solution of this question is still called the division of 2/3 by 4/5, and the fraction whose denominator is the number of parts into which 4/5 is divided, and whose numerator is the number of them which is taken, is called the quotient. The solution of this question is as follows. Reduce both these fractions to a common denominator, according to Article 111, which does not alter their value, according to Article 108. They then become 10/15 and 12/15. To the question, the question now is to divide 12/15 into a number of parts, and to produce 10/15 by taking a number of these parts, since 12/15 is made by dividing 1 into 15 parts and taking 12 of them. If we divide 12/15 into 12 equal parts, each of these parts is 1/15. If we take 10 of these parts, the result is 10/15. Therefore, in order to produce 10/15 or 2/3, according to Article 108, we must divide 12/15 or 4/5 into 12 parts and take 10 of them. That is, the quotient is 10/12. If we call 2/3 the dividend and 4/5 the divisor, as before, the quotient in this case is derived from the following rule, which the reasoning will show to apply to other cases. The numerator of the quotient is the numerator of the dividend multiplied by the denominator of the divisor. The denominator of the quotient is the denominator of the dividend multiplied by the numerator of the divisor. This rule is the reserve? No, that was not correct. Is the reverse. That's right. The reverse is the reverse of multiplication, as will be seen by comparing what is required in both cases. In multiplying 4 over 5 by 10 over 12, I ask if out of 4 over 5 by taken 10 parts out of 12, how much of a unit is taken, and the answer is 40 over 60, or 2 over 3. Again, in dividing 2 over 3 by 4 over 5, I ask, what part of 4 over 5 is 2 over 3? What part of 4 over 5 is 2 over 3? The answer to which is 10 over 12. And there we go. That's the conclusion of 121. Moving on to 123. Grab a quick sip of water. Article 122, move down the page. By taking the following instance, yeah, it's instant. So what is instance? Same thing. We shall see that this rule can be sometimes simplified. Simplified. I know simple is it's simp, S-I-M-P, and then fied, simplified. Let's go ahead and check that out. Take a look. Okay, so it's simply simp and then add an F to the end to get simplify. And then we just add a disjointed D below that. Very nice. Divide 16 over 33 by 28 over 15. Observe that 16 is 4 over 4. 4 times 4, not 4 over 4, is 4 times 4, and 28 is 4 times 7, let's see here. 33 is 3 times 11, semicolon, right? Yes. And 15 is 3 times 5. Therefore, the two fractions are laid out 4 over 4, or 4 times 4, and that's all over 3 times 11. And 4 times 7 over 3 times 5. And their quotient, according to the rule, is, if we add them up, it is 4 times 4 times 3 times 5. All over 3 times 11 times 4 times 7, in which 4 over 3, or 4 times 3, is found both in the numerator and denominator, in which 4 times 3 is found in both the numerator. Need to add another page. Elements of Arithmetic. Section 5, page number 13. Where was I? The fraction is therefore in which 4 times 3 is found both in the numerator, in the numerator, and the denominator. The fraction is therefore, according to Article 108, the same as 4 times 5 over 11 times 7. Or 20 over 77. The rule of the last article, therefore, admits of this modification. Isn't that just AMITS for admit? No, it is AM. It's just not the AD stroke. It's AM admits of this modification. Modification. Mod. Some sort of mod. Yeah, very nice. Modification. Excellent. If the two numerators or the two denominators have a common measure, divide by that common measure and use the quotients instead of the dividends. All right, and that is quotients instead of the dividends. So that's all of 120. That's all of 122. Which means I'm somewhat torn as far as whether I want to add any more to this document, or I think I might create a second portion. Should be the better way. So let me go ahead and check, because we have 123, we have exercises. Oh, are we right at the end? 123, 124. Oh, okay. We are close to the end. We are close to the end of section 5. So I think we can definitely fit it all in one document. Nice. So let's go ahead and reread over 122, and then we will dive into 123. Where does 120... 122 by taking the following instance is what I'm looking for. 122. That's cases. 10 over... Dun dun dun. Come on now, where are we? Where are you, my friend? Okay, there's our values there. Observe. There it is. All right. We begin 122 by taking the following. By taking the following instance, comma, we shall see that this rule can be sometimes simplified. Divide 16 over 33 by 28 over 15. Observe that 16 is 4 times 4 and 28 is 4 times 7. 33 is 3 times 11 and 15 is 3 times 5. Therefore, the two fractions are 4 times 4 over 3 times 11 and 4 times 7 over 3 times 5. And their quotient, according to the rule, is 4 times 4 times 3 times 5 all over 3 times 11 times 4 times 7, in which 4 times 3 is found in both the numerator and the denominator. The fraction is therefore, according to Article 108, the same as 4 times 5 times 11 times 7, or 20 over 77. The rule of the last article what is that? Admits. That's right. Admits of this modification if the two numerators or the two denominators have a common measure. Divide by that common measure and use and the coefficient instead, and use the coefficient instead of the dividend, instead of the dividends. The quotients instead of the dividends. Very nice. Now we go ahead and start in on 123. By dividing a fraction by a whole number, for example, 2/3 by 15, consider 15 as a fraction 15 over 1. The rule gives 2 over 45. as the quotient. Therefore, to divide a fraction by a whole number, multiply the denominator by that whole number. And then these are all the exercises. Oh man, how wording has changed. How wording has changed. Like A can reap a field in 12 days, B in 6, and C in 4 days. In what time can they all do it together? In what time would a cistern be filled by cocks? And that's the cock crow, which would separately fill it in 12, 11, 10, and 9 hours. Answer 2 and then 4,450, 4 hours over 763. That's really nice. Actually, these word problems are quite good. Once I'm done copying this and we're done with the review, this would be great material to go through. Huh. Okay. So that was it for 123. In dividing a fraction by a whole number, for example, consider 15 as a fraction. The rule 2 over 45 as the quotient. Therefore, to divide a fraction by a whole number, multiply the denominator by that whole number. So that's just a matter of remember that a whole number can be a fraction. Okay. So we can go ahead and skip all that. And now we can go and start listing out the rules in 124 because we're pretty close to the end of this section. Be great if we can finish this section tonight. So, let me grab a little sip of water. Oh, sorry about that. Knock the microphone to Kingdom Come. Okay. Let us proceed. Article 24. The principal results of this section may be exhibited algebraically as follows. Ooh, exhibit. What is exhibit? I don't know. Let's go ahead and check. Exhibit. Exhibit A. There we go. may be exhibited algebraically as follows. Let A, B, C, etc. stand for any whole numbers. A then, and then it lays out, it's a review of all the previous, articles. According to Article 107, A over B is equal to 1 over B times A. Article 108 states that A over B is equal to MA over MB. Article 111 guess these should all be in parentheses for standardization. So there's Article 107, Article 108, Article 111 down below. Same thing in parentheses. It states that A and B, A over B and C over D are the same, as AD over B, AD over BD over BD, and, might have to do this on a separate line, and BC over BD. BC over BD. Okay? Number 12. That should be on its own line. Let's do number 12 here, and I'll see if I can write just a little smaller. Number 12 states that the sum of A over C and B over C, the sum of A over C and B over C is the equivalent to the sum of A over, or A and B over C. And conversely, A over C minus B over C is the equivalent to the difference between A and B over C. All right, so there's our 12th value, or the 12th article, and then the 13th article is more of the same essentially, except now we're expanding if we have different denominators. This is how we deal with the case of disparate denominators. We have 113 is the article from which this rule, or which lays out this rule, and it states that A over B plus C over D, notice difference in denominators, is the equivalent to the product of A and D plus the product of B and C all over the product of the denominators, which is B and D. All right. Now conversely, run myself out of room, I need to demonstrate the delta, or the difference between those. So if you have the difference between two fractions, A over B and C over D, this can be resolved in the same manner, where you take the product of A and D subtracted from the product of C of B and C, and that is also over the denominator of B and D. All right, the final one is Dun, 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 dun. Oh, that's nice. He gives the little example of how to find the method of solving. If the number of days in which each could reap the field is given, yeah. Okay, sorry, I got a little sidetracked. Let's go back to 118, 118 below. 118. This states that A over B times C over D times C over D is the equivalent to AC over D, or BD. All right, and then the final one is AB divided by C over D. Or, and then he shows the actual fraction. For us, we can do we can use the fractional symbol, or we can use the colons as well. So down below, Article 121 lays out how we're supposed to deal with the division of fractions. If you have A and you have B, A over B, and let's do the ratio symbol, so that's the two dots, A over B divided by C over D. This is going to be the equivalent to A over D times, let's go ahead and show the flipping of the reciprocal first, D over C, which is then the equivalent of A D over B C. And that is, those are all the rules. Those are all the algebraic rules, or actually the arithmetic rules for dealing with fractions, okay? And then he gives some more explanation in 125, and that's it. So let's go ahead and, do we need to do 120? He laid out the rules for 120. Okay, we already did 122, and then in 124, he was essentially just laying out rules. which we don't need to read back over. So I'm going to skip that, and I'm going to go straight to article number 125. Article number 125. I have a feeling this one's going to be a little bit more intensive. So let's go ahead and get it going. These results are true, so we have 125. These results are true even when the letters themselves represent fractions. Represent. For example, take the fraction AB over CD. I'm going to make it linear by going AB, use the colon operator again. They're called the ratio. Whose numerator and denominator are fractional. And multiply its numerator and denominator by the fraction, E over F. Which gives and over here we're going to go same thing, go AE over BF, use our colon operator, CE over DF. Oh, and I did my C backwards. CE all over DF, comma, which according to Article 121 is the multiplication by the reciprocal, which gives us AE DF all over BF, C, and E, which, dividing the numerator and denominator, so you see here, you can simply just parse it back out. So which, dividing the numerator and denominator by EF, which dividing Not numerator, it's numerator. By EF, according to Article 108, is A over D, or AD, over BC. But the original fraction itself is AD over BC. Original is what is that? Is it? I think it's that. No, that's origin. Let me check up original. Ah, there it is. But the original fraction itself is AD over BC. Hence, so semicolon, hence, AB divided by CD is the equivalent to, it's the equivalent to multiplying the value by a fraction. So it's the equivalent to, I'm just going to lay it out this way. A over B, I'm going to put this in parentheses, divided by C over D, and this whole thing is multiplied by E over F. And then using the communicative, no, the, not the commutative law, it's the associative law. No, it would be the distributive law. So we have E over F, and then it would just distribute out to the other two terms, which corresponds to the second formula in Article 124, which, corresponds. Oy, what is correspond? Check it out. There we go. Which corresponds, there we go, to the second formula in 124. Formula. There it is. In Article 124. In a similar manner, it may be shown manner is this stroke right here. It may be shown in a similar manner. It maybe, yeah, shown that the other formula of the same article are true. Formula of the same article are true when the letters they're used can I do this all? Yeah, maybe I can do it all on one column. I'm going to go ahead and add another column here just in case. There we go. And this will be 14. Alrighty. They're used. That the formula of the same article are true when the letters they're used either represent fractions or are removed and fractions introduced in their place, or are removed. Removed? For some reason I'm blanking on that. Yes. Or articles are the fractions are removed and fractions introduced in their place. Are removed and fractions introduced in their place. Fractions introduced in their place. All formula established through this, established, EST, and then disjointed, not established ability. Let's look up established. ESTB, established. Throughout this work are equally true. Throughout this work are equally true when fractions are substituted. That is SST, right? SST, and then a disjointed T. Correct. It's just that it is a, it's not a curved S, it is a jointed S. There we go. Substituted. When fractions are substituted for whole numbers. For example, Article 54 states that if we have the sum or the product of a value and a sum, in this case it is a times m plus n is going to be equal to ma and na. All right, that's simply the law of distribution. So the law of distribution works for fractions as well as for regular numbers. And then it says let m, n, and a be respectively the fractions. So now we actually work it out. Let m, n, and a be respectively, that is R, E, S, and then I think it's a disjointed V underneath. Check it out. It's respective, and then so respectively would simply be the little circle vowel on the end. Okay. Respectively, the fractions P over Q R over S, right? R over S, and B over C. P over Q, R over S, and P over C. And it does open up good. Then, so we work this out, then M plus N is equal to P over Q plus R over S, or P over Q plus R over S, or PS plus QR all over QS. And so that's the value. And M plus N, open parenthesis, M plus N times A is therefore going to be, if we do substitution, then we get PS plus QR all over QS times B over C. Or, if we then work it out, or we then distribute, let's go ahead and skip that middle stage, that middle stage right there, and go straight to the answer, which would be the distribution. So we're PSB plus QRB all over QSC. All right, but this, according to Article 12, is, and we show it here, it is PSB over QSC, all right, plus Q, nope, it curves back, there we go, QRB all over QSC, which is, oh, well, this is brain twisting, which is PB over QC over QC plus RB over SC. Okay, since, all right, he's really laying it out here. Since PSB is over QSC over QSC is equal to PB over QC, and QRB, yep, QRB is over QSC is equal to, if we pull the common factor out, which in this case it's Q, we're left with RB over SC. That's according to Article 108. But, all right, here we go. But, PB over QC is equal to P over Q times B over C, and RB and RB over SC is equal to R over S times B over C. Therefore, and it's just demonstrating it out. Okay, therefore, M plus N times A, or P over Q plus R over S times B over C is the equivalent to P Q times B over C plus P over Q times B over C plus R over S times B over C. There we go. Okay. Wow. That was wild. In a similar manner, the same may be proved by any other formula. Thank goodness. In a similar manner, the same may be proved for any other formula. And the following examples may be useful. I'm not going to worry about about examples right now. A formula is a name given to any algebraic expression which is commonly used. All right, so we could work all those examples out, and those are very useful. Like I said before, though, that's not really what I'm about at the moment, so I'm going to skip that. And that's actually the end. So look at that. With 2 minutes left to spare, we have the final statement, which is the rules that have been proved to hold good. The rules that have been proved to hold good for all numbers may be applied when the numbers are represented by letters. And let me check represented. Represent. That's it. Represented by letters. Yay! And that, my dear friends, ends section number 5, which is really neat because that means that I completed a whole section in a day. Not too shabby, not too shabby. And that was what, 13 pages of material? So, you know, pretty good, I'd say. So we started with section 5 this morning, and so that was what, 7 hours? Because we did 7 hours of copywork today. So in 7 hours, I copied 13 pages of material, or what was the equivalent to 13 pages, which means I can go ahead and get rid of this Control-Shift. There we go. Very nice. I like that. I like that a lot. I'm very happy with that. So, that's it. That is all 13 pages. Wow. And all of section 5. So now we go into decimals is next. We take a look at that. Let's see. How many more pages does this have? I probably will have to end up truncating it, but I'm pretty sure that it's 217 pages. It's 217 pages of material, but man, hold on, let me minimize. I'm gonna minimize. Well, actually, no, I'm not gonna change the view. I'll just put it back here. So we're back here. Yeah, not much more to say today. That was 7 hours. I think what I'm going to try to do going forward is to maintain a stream integrity of 7 hours. So, 7 hours over a 6-day period, that's 42 hours. Not bad. Not bad for study material. And yeah, so that's all I have to say about that. It was a good day. Got a lot done. Thank you very much for perusing this. If you get to this level, I wish you all well, and I will see you tomorrow, same time, same station, with more copywork. So thank you so much to everybody who popped in, who is interested in whether it's mathematics, whether it's Gregg Shorthand, whether it's learning kind of the old way of doing things. It's all much appreciated, and the more knowledge we can build. Oh, hello, Mia, hello. I see you just popped in, so good to see you. Thanks for joining for the last little bit. I was able to get some of the streaming done a little bit earlier on my end. It just turned 7 o'clock for me. So anyway, yeah, that's it for now. Thank you so much, and I hope you had a wonderful day and that you were able to accomplish everything that you set out to do. So have a wonderful evening, and I will be back at it tomorrow. Take care. Bye-bye.